Our lesson today deals with water purification. Communities obtain their water from two sources, groundwater and surface water. Groundwater is what percolates through the soil and accumulates below the water table. It is obtained by drilling wells and then pumping the water out. Surface water is that which collects in lakes, oceans, rivers, and streams or reservoirs. Before water from either source can be used for drinking, it must be treated to remove any unwanted ions, suspended solids, and to destroy any pathogenic microbes that might be present in it. This involves a number of processes as shown in the figure below here. So we go to figure 16.2, but I want you to read what is happening at different points. It's very straight. Coagulation and flocculation. I'll show you the diagram. In this process, coagulants are added to allow dissolved solids to clump and form larger particles called floc. The coagulants commonly used are sulfates of iron and aluminum. What these coagulants do is that they remove the negative charges from particles that cause them to repel each other. So when these negative charges are removed, say from colloidal materials and stuff like that, they clump together and they form what is called floc. After floc formation, the water is then sent to what is called a sedimentation tank. So you add your coagulants and you send the water through a sedimentation tank where the water sits for some time. They neutralize heavy particles from the coagulation process, settle out as sludge by the force of gravity. This process is called sedimentation. The sediments, sludge, are removed from the sedimentation tank mechanically. So the water now has been cleansed of all those solid particles by sedimentation, and in that container there, it is removed mechanically. Then you have what is called filtration. After all the floc has settled to the bottom of the sedimentation tank, the water is then passed through a filter bed to remove any remaining dissolved solids, odor, some chemicals, and microscopic organisms. The filter bed is composed of activated charcoal, gravel, and sand particles of selected sizes to ensure that most of the contaminants are removed. The filtered water is then sent for further treatment, what is called disinfection now. To ensure that there are no remaining harmful microorganisms present in the filtered water, it is treated with one of many types of disinfectants. These include chlorine, chloramines, UV, chlorine dioxide, or ozone. Some anti-corrosion agents may be added also to prevent corrosion of lead pipes. What municipalities are doing now, those who can afford, they're replacing all those lead pipes with less dangerous things like plastics and so on. In affluent countries, lead pipes are gradually being replaced by ones that are safer. So these are the processes, and this depicts what is happening here. So that's my beautiful lake there. So water from the lake or reservoir is pumped into this tank here, and this is where coagulants are added. Right? So coagulants work by neutralizing negative charges and dissolved solids by making them cluster, clump, and settle out of solution. So after the coagulants are added here, the water is then sent into the sedimentation tank here. So when it sits there for some time, it allows all those sediments to settle down here as what is called a sludge. So from here, this sludge is removed mechanically. So above here is the water there, clear water there, okay? Now we still have to treat that clear water just to remove any remaining solids and stuff like that. So the water is then sent to this filter bed here. Filter bed consists of particles of different sizes. You have gravel here, you have coarse sand, fine sand, different grades of sand, and at the top here you have something called activated charcoal. As the water passes through here, and this charcoal here is capable of removing like odors from the water, certain poisons that which are harmful to human beings, right? So remove those things there, and then you can see these different particles. They're very small. They're clumped together. So as the water passes through here, any solid material is removed from it. So the water comes here now, but it still has pathogens, or maybe still having some kind of microorganisms that can be harmful to human if ingested, okay? So it comes into the disinfectant chamber here, all right? The bacteria and viruses are killed by use of agents such as chlorine, chloramines, ozone, or UV. And then finally here, you have pH regulation. You still want the water that goes out there to have a pH very close to 7. So they add different chemicals there. If you have, if it is acidic, they probably add some calcium carbonate there that will react with the acid to neutralize it. So the water that goes out here is pretty safe to drink. But note that even in the sewage treatment plant and this purification process here, heavy metals such as lead and mercury and all of those things that were perhaps present in the water in the lake there, nothing has been done to effectively remove them from the water. Okay, so this is the water that you'll drink in a fountain, from your pipes in the kitchen, that goes into your fridge, that makes ice and all of those kind of stuff, right? Some people treat the water a little bit more, like in the refrigerators, they'll have like a filter there, and that filter is able to remove certain substances to maybe some hydrocarbons, and maybe, filter some of the agents there out of the water. So here we have the Canadian guidelines for drinking water. All right. So we can all read that together. I'm not the best reader, as you can see that. Reading ability has eluded me. Since water can be contaminated by various types of pathogenic organisms, organic and inorganic substances which may be harmful to human health, Health Canada, in its guidelines for Canadian drinking water quality, and this is the website there if you want to visit that, has set certain criteria that decide what contaminants are safe to be in drinking water and what are not. The guidelines have established strict control on the levels of contaminant permitted to be in water based on known health effects associated with each contaminant, exposure level, and availability of treatment. The level of each contaminant is deemed to be safe in drinking water is referred to as its maximum acceptable concentration, MAC. Water having any contaminant that exceeds this maximum concentration is deemed unsafe to drink. The guidelines may be reviewed from time to time to address any issues or problems that may arise, or from the findings of ongoing research with respect to the various contaminants. The following table gives a few chemicals, their max, and their sources. All right? Let's look at these tables here. All right. The values provided are measured in parts per million. The sources of this is industrial waste and spills. Lead, again, leaching from lead pipes and lead appliances. Fluorine, erosion of rocks and soil. Nitrate, runoff from farms, fertilizer use, and sewage. Industrial spills. So these are a few, just to give you an idea, but every different contaminant has its own maximum acceptable concentration. Maximum acceptable concentration. So some questions here that refers to. All right. So here's a comparison of two samples of water with contaminants. It's a question for you to do. All right. So another example for you to do, showing two sources of water there, A and B. All right, for you to practice those. All right, so that was how water is purified. Okay, I hope that was useful.